Today we are going to graph rational functions. Last class we graphed reciprocal functions. These are very similar, but the difference is we have x in the numerator and the denominator. First thing that we're going to do is fill out this chart. And this chart is for an acronym that we use when we graph rational functions. I don't even know that it's an acronym, because I think an acronym is a word, but I don't think this is actually a word. But in any case, maybe it's called a mnemonic device. Maybe that's what it is. But we are going to learn about Baharete. And this is what we use when we graph rational functions to help us remember all the pieces that go into graphing. First, you have to factor. There's nothing that goes along with that. You just have to make sure that you factor first. Aiden. Next, wholes. Wholes come from terms that get canceled. Something out, and on the graph it shows up as a whole. So it's whenever we mark out a factor. So it's canceled factors. That's where we find them from. And we're going to find the x from the canceled factor. And then what we're going to do is plug in x to solve for y. And you only have to do that if there's canceled factors and there's a whole. Not every time you're graphing is there a whole. So only if there's a whole. Next, our roots. Roots are actually x-intercepts or zeros, all the same words. We're going to illustrate them on the graph with a point. I put a point over here. They're represented with a point on the graph. And we find these from the numerator, or we find them from the top. They come from the numerator or the top. So the top of the fraction. Asymptotes. Asymptotes. These are actually vertical asymptotes. So I'm going to show you with a dashed line, because that's how you're going to see it on the graph, with a dashed line. And we find these from the bottom or the denominator. You find these from the bottom or the denominator. So they go in order. Roots come from the top, and then we find asymptotes that come from the bottom. Togetherness. We talked about togetherness a little bit last class, and togetherness happens when a factor is what? Anybody remember from last class? Even. So togetherness happens when a factor is even factors. An even factor. And anytime I see the t today, I'm going to square it, because that's what we're pretty much looking for. Like, I'm not giving you something to the fourth power. That's more like pre-cal, but anything with an even factor, it's going to have togetherness. And what we learned last class is what it looks like if you have an asymptote. And around an asymptote, your graph is going to go like this. They go together. So remember that that's what togetherness looks like at an asymptote. Today, we're going to look at also what it looks like if you have a root. So if you have an x-intercept and it looks like that, togetherness, your graph is going to go away as it hits the root, and then it's going to go away in the same direction as it hits a root. So this is what togetherness looks like when it's at a root. So when something is squared on the top, or when something is squared on the bottom. So if it's squared on the bottom, it's around an asymptote. Squared on the top, it's around a root. And again, this is representing togetherness. These are together. These are together. End behavior. End behavior represents my horizontal asymptote. So last class, we learned that every reciprocal function has both a horizontal and a vertical asymptote. Same thing with reciprocal functions. They're going to have a vertical and a horizontal asymptote just the same. So the vertical asymptotes come from the bottom. That's what these are. The horizontal asymptotes, they come from, and so they're horizontal. They're like this. That's what they'll look like on the graph. These come from the ratio of the x's. So you just count how many x's are on the top in relation to how many x's are on the bottom. So if there's the same amount of x's that there are on the top and on the bottom, it ends up being the ratio of the leading coefficients. And pretty much what we're dealing with is like just x, not like 2x, just x. So most of the time when the degree on the top and the bottom is the same, it ends up being y equals a over b, which are the ratio of the leading coefficients. Most of the time it's 1, so it ends up being y is equal to 1. Actually, I'm going to call it not equal because it's not going to be equal at that point. It's an asymptote. Now, the equations of the asymptotes are actually x equals or y equals. But here, I'm going to say x is not equal to, because that's kind of referring to the domain. X can't be equal to those things. Same thing here. End behavior helps you determine the range, and it's when y is not equal to this value. Your graph doesn't touch it. When you have a big bottom, y is equal to 0. When you have a big bottom, y is equal to 0. So I'm going to say y is not equal to 0. Boys, please. Last day of notes. Let's get through it. Big bottom means y is going to not be equal to 0. That's where your asymptote is. And when you're bigger on top, we're not doing any of these types, but you get actually not a horizontal, but a slant asymptote, and you have to divide. Not for us. You would do that in advanced, or you will definitely do it in pre-cal. So slant asymptotes, and you will divide. These are good notes, by the way. Those of you that like to keep things, this is actually something that you will definitely wish that you have when you take pre-cal. These are good notes. In fact, everything that we've learned all year kind of culminates with today's lesson. That if we had more time, we would do over a series of days. So everything kind of ties together with what we're doing today. Last, we have y-intercept, and y-intercept will be represented on the graph with a point. And so I put a point here. And the y-intercept is going to be equal to, we figure it out because we plug in 0 for x. So plug in x is equal to 0 to find y. And we're going to represent it as x is always 0, and then we're going to solve for this y value. So this is how we're going to write our point. All right, this gets us started. Now we're going to actually find some stuff. The first problem, I cannot solve it or find any of these things until I have factored the denominator. And so I'm going to have to factor the denominator. I'm going to leave the numerator the same. So I got to figure out two numbers that can multiply to give me 2 that can add or subtract to make 1. What multiplies to give you 2? 1 and 2, that's all we got. So 1 times 2, and my middle term is negative, so the bigger number is going to be negative. If I have negative 2, I would have to add 1 to make negative 1. So I'd have to add 1. So now I am fully factored, so I can check off that I am factored. For wholes, do I have any factors in the top that repeat in the bottom? All right. So anytime that this happens, you have a whole. So I can mark these off, and I'm going to denote that I'm going to have a whole. So I'm circling whole because I need to write some stuff in there. The whole is going to happen, and we always do the opposite of the things that are in parentheses. So the whole is going to be at x is equal to positive 2. So I'm going to jot that down really tiny right here because we're going to write a lot in that box. X is equal to 2, jotting that down. I'm also going to rewrite this. So we have x minus 4 in the numerator, and then x plus 1 in the denominator. You don't have to have parentheses. If you didn't write parentheses, it's okay. All right, so we are fully factored, and we are going to have a whole. To figure out the y part of the whole, I am plugging in the x value. So really tiny, I'm going to figure this out to figure out the y part of my whole. I'm going to plug in x is equal to 2 up here. So I'm going to have 2 minus 4 over 2 plus 1. So I'm plugging in the x value into my equation here, or my expression here, to figure out the y value. So in the top, I have 2 minus 4. What's 2 minus 4? Negative 2 over what's 2 plus 1? 3. Okay. That doesn't reduce, and that's okay. It doesn't have to. So the point of my whole is going to be the x value, which is 2, and then my y value, which is negative 2/3. So this is the point of the whole. If I had to graph it, which I'm not graphing this one, I would have to make sure that I mark the whole. Moving down the list, roots come from the top and they are points. So I'm going to note it with a point. Roots come from the top, and it's going to be opposite. So x is equal to what from the top? 4. X is equal to 4. From the denominator is going to tell me where my asymptotes are, and these are going to be vertical asymptotes when I go to graph. And these are places that are restricted from the graph. Your graph does not live there. So I'm going to say that x is not equal to these numbers. So x is not equal to the things from the denominator. So x is not equal to what? Negative 1. Okay, moving down the list. Togetherness. Togetherness happens when a factor is squared. Are any of these factors squared? No. So I'm going to say none. There is none togetherness. End behavior, when I go to graph, is going to be represented by a horizontal asymptote. And when I was talking about the ratio of the x's, how many x's do I have on top? And the bottom? Do I have the same or a different number on the top and the bottom? Same. So what I'm looking for is the ratio of the leading coefficients. Okay, well, what's the number that's in front of the x? Okay, what's the number that's in front of this x? What's 1 over 1? 1. So my in behavior, y is not going to be equal to 1 when I go to graph it. So this is part of my range. Y cannot be equal to 1. Y represents my y-intercept, which is a point on the graph. So I'm going to mark it with a point. And to figure it out, I'm going to figure it out because it's always when x is equal to 0. So if this was a 0, it's like it doesn't even exist. So all that I'm left with on the top is -4 or -4. And if this was a 0, it's 0 plus 1, which is just 1. What's negative 4 divided by 1? Negative 4. Okay, so I know my x value and I know my y value of my y-intercept. X is always 0 and the y part is negative 4. That's it. If we had to graph, we would, but that's all I'm figuring out. Next problem, factor first. The denominator is factored, the numerator is not. So I'm going to look at my numerator and I'm going to try and figure out what two things can I multiply to make 30 that could put together to make 13. Think of factors of 30.
Oh.
Ten and 3 will work. So 3 and 10. My middle term is positive, so the bigger number needs to be positive. In fact, they're both positive, so these will both be positive. Any repeated factors in the numerator and denominator? Anything cancel out? All right, so I am factored and none for wholes, which is nice because finding that y value isn't super fun. Okay, roots. Roots are going to be a point on the graph and they come from the top. So x is going to be equal to what and what? Yep, x is equal, oh, wrong spot. X is equal to -3 and -10. Asymptotes. Asymptotes come from the denominator. And I'm going to note that right on the side. It's going to be a vertical asymptote, comes from the denominator. And I know what this one is. That's going to be what? -2. And I'm going to say that it's not equal to -2. And the other one, what is it when x is by itself? 0. Good. Togetherness is anything squared. No, so I'm going to say none. We have to check for it, even if it doesn't happen very often. And behavior is going to be my horizontal asymptote. So I'm going to make myself a little note. It looks like that. It's going to be a horizontal asymptote. And to figure that out, I'm going to look at the ratio of how many x's are on top and how many are on bottom. That's looking at the degree, the amount of them. So how many x's on top? 2. How many on bottom? 2. So it's the same. If we multiplied them out, what's the number in front of this x? 1. What's the number in front of this one? 1. What about this one? And 1. Okay, so it's 1 over 1, which is just y is equal to 1. So we're going to say that y is not equal to 1 because it's our range. It's not going to be equal to 1. My y-intercept is going to be a point on the graph. So I am going to plug in 0 for each one of the x's. And when I do that, in my numerator, this is going to be 3 times 10 because the x's don't matter. They're 0. So it's going to be 3 times 10 over 0 times 2. Okay. What's 0 times 2? What happens when you divide by 0? Undefined. Okay, if it's undefined, that means you don't have a y-intercept, so there's none. And the reason why there's not a y-intercept is because your graph, you have an asymptote at 0. so your graph can't live there. We're done with that one. Next. Yes. The next one, I am not factored, so I need to factor this. My numerator is good, x plus 2, but my denominator, I have to think about what two things can multiply to give me 15 that could put together in such a way to make 2. 5 and 3 will work. 3 and 5. Y'all are getting good at fast factoring. My middle term is positive, so the bigger number is going to be positive. And if I have 5, I would have to subtract 3 to make 2. And a negative times a positive will multiply together to give me a negative. So I'm fully factored. Are there any repeated factors in the numerator and denominator that can cancel out to make a whole? No. So I am factored and none for wholes. Please do not put 0 for whole. Otherwise, it kind of implies that there's a whole at 0 and there's not. So just say none. Okay, roots come from the top. Looking at the top, what are my roots? What is x equal to? -2. In the denominator, these are my vertical asymptotes. And x is not going to live there. So I'm going to say x is not equal to what and what? +3, -5. And this is a list that is not ordered, so I don't really care which one you list first. I usually just go in order left to right, but maybe on an assessment, it might have them in numerical order. The order doesn't matter. Togetherness. Do I have any factors that are squared? No, so none. End behavior. End behavior is going to be my horizontal asymptote. And I'm going to say that y is not equal to, and I've got to look at the ratio. I have 1 x on top, and how many x's on bottom? 2. When you have a big bottom, it's y is equal to 0. And we're going to write it as y is not equal to 0 because the graph doesn't live there. Y is not equal to 0. Y-intercept. This is when x is equal to 0. So if I pretend like the x isn't there, I'm going to have 2 over -3 times 5. And I'm going to write that out. So my y-intercept is going to be 2 over -3 times 5. So all I'm doing is ignoring the x part because it's 0. So 0 minus 3 is -3. 0 plus 5 is 5. So I'm going to multiply that out. So I get 2 on the top. That doesn't change. What's -3 times 5? -15. So these are ugly, and that's okay. I end up with -2 over 15, but I'm going to write it as a point. So I end up with 0 and then -2 over 15. It doesn't really matter if you know exactly what -2 over 15 is. It's a number between 0 and 1, and it's small. So somewhere between 0 and 1, you put a hole when you go to graph it. You don't have to be exact. And we're almost halfway done. Moving on to the back. For question number 4, does this need to be factored? No, we're already factored. Are there any holes? There's nothing to cancel out, nothing in the numerator and denominator that is the same. So I'm going to say none. My roots are going to be a point, and they come from the top. What is it when there's an x by itself? Yep, so x is equal to 0. My asymptotes. These are vertical asymptotes, and I'm going to say that x is not equal to them because your graph doesn't live there as part of your domain. So x is not equal to what from the bottom? -5. Togetherness is anything squared? No, so there's none. End behavior is going to be the horizontal asymptote. And I get that by looking at the ratio of the x's. So what situation do I have? How many x's on top and how many on bottom? One each. And what's the number in front of both these x's? 1. So it's 1/1, or just y is not going to be equal to 1 for your range. Y-intercept. My y-intercept is when x is equal to 0. And to solve for that, I'm going to plug in 0 for x. So in my numerator, I get 0. And in the denominator, I just get 5. So I have 0/5. What's 0 divided by 5? 0. So my point for my y-intercept is going to be 0, 0, or the origin. Next problem. Am I fully factored? No. That numerator can be factored. It's actually a difference of perfect squares. What's it going to turn into?
5 squared.
Nah. What does this turn into? Yes, x plus 5, x minus 5. All right, do I have any holes? Yeah, x minus 5 and x minus 5 can cancel out. So I definitely have a hole, and the hole is going to be at 5. It'll be at 5. X is equal to 5. And I'm going to go ahead and simplify. So I'm left with x plus 5 in the numerator and then just x in the denominator. To figure out the y part of my hole, I'm going to plug in x is equal to 5. So I get y is equal to, in the numerator, I'm going to have 5 plus 5. And in the denominator, I'm just going to have 5. Oh, no. I rewrote this incorrectly. Anybody see what I'm missing? I'm missing the square part. Oops. All right, now, there we go. So 5 plus 5 is 10. And then what's 5 squared? 25. Can we reduce that? They're both divisible by 5. So yes, you are correct. It becomes 2/5. So the point of my hole is 5 and then 2/5. My roots, they come from the numerator, and they're going to be a point when we go to graph. Boys, I'm going to move you. Stop. It would be different if y'all were quieter. You're not quiet. The root comes from the numerator, and it's going to be what? What is it? Yeah, what is your question?
One's negative, one's positive.
I don't know what you mean.
So. X, Y equals. I didn't Y.
I'm plugging in what the X value is into this. So for this one, X is 5. So in the numerator, I have 5 plus 5, which ends up being 10. And in the denominator, I plug in 5. 5 squared is 25. So I'm plugging in what this is. And so since I canceled out the X minus 5, the X part, remember, it's always opposite. So since it's minus 5, the X is equal to 5, positive 5. Okay, roots. X is equal to what? From the numerator at the top. Yes. Asymptotes. These are vertical. They come from the denominator. It's where X does not live. And so what is it when it's an X by itself? It doesn't matter if there's something squared. What was it here? It's gonna be the same thing. X by itself is just 0. Togetherness is anything squared. Yes, we do have togetherness. Yes, there is togetherness. It's the first one that we've had that has togetherness. And so this is together. Around that asymptote, it will be together. So make sure you give yourself a note so that when you go to graph, you make sure that you graph it and there is togetherness. And behavior, that is an asymptote. It is horizontal, and we're looking at the ratio of the x's. So how many x's on top? We've got 1 on top, 2 on bottom. Anytime you have a big bottom, it is 0. So y is not going to be equal to 0 in our range. My y-intercept, I'm going to mark as a point when I go to graph. And to figure out the y-intercept is always when x is equal to 0. So I'm plugging in 0 for x. So in the numerator, I have 0 plus 5, or just 5. And then I have 0 squared, which is just 0. What happens when you divide by 0? It is undefined. If it's undefined, then what is your y-intercept? Yeah, you don't have one. All right, we are done. The next problem, am I factored? For the next problem, am I fully factored? Yeah, the top has to be factored still. So I need to factor the top. And for the denominator, it's going to stay the same, x plus 2 and x plus 4. Two things can multiply to give me 12 that can add or subtract to make 4. 6 and 2 will work. So I'm going to plug in 2 and 6. My middle term is negative, so my bigger number needs to be negative. If I have negative 6, I would have to add 2 to make negative 4. And positive times negative will multiply to make a negative. So I'm fully factored. Do I have any holes? Yes, I have a hole. So when I go to graph it, I would have a hole. The x plus 2's can cancel out. That means that the hole is when x is equal to negative 2. I'm going to rewrite it. So I have x minus 6 over x plus 4. I'm going to plug in negative 2 to my reduced form to figure out the y part. So y is equal to, in the numerator, I'm going to have -2 minus 6. -2 minus 6. And then -2 plus 4. What's -2 minus 6? -8. And then 4 minus 2 is 2. What's -8 divided by 2? -4. So now I know the coordinate of my hole. It's going to be at -2, -4. My roots, they're going to come from the numerator. So looking at the numerator, looking at the top, what is x going to be equal to? Yep, x is equal to 6. And then looking at my denominator, that's where my vertical asymptote will be. And that's where my graph does not live. X does not equal to -4. Very good. Do I have any kind of togetherness? Any squared factors? No. In behavior is my horizontal asymptote. And to figure that out, I'm looking at the ratio of the x's. How many on top? How many on bottom? 1 and 1. The number in front is 1. So y is not going to be equal to 1. My y-intercept, that is always when x is equal to 0. So if I go plug in 0, I'm going to have 0 minus 6, or just -6 on the top. And in the denominator, I'm going to have 0 plus 4, or just 4 in the denominator. Does that reduce? So we'll get -3 over 2 as my y part. For the bottom. Yes, y-intercept, the definition of a y-intercept is when x is equal to 0. Yes. The last two questions depend on question 4 and question 6. We've already filled out all of this stuff. So now we're actually going to graph and we're going to find solutions. You can figure out the solutions before you ever even graph, because a solution is the same thing as the roots. That's all it's asking for. So for this problem, what is x equal to? 0. That is what is in your solution set. You can answer that before you ever even graph. So now what I'm going to do is I'm going to go through and I'm going to mark my graph with any of the critical values. And so the critical things are these things that I put out to the side. We mark our graph with these things first, and holes if there is any, but for this problem, there's no holes. So I'm going to mark dots for any kind of roots, and I'm going to mark asymptotes with dashed lines. So I have an x-intercept at 0. So I'm going to go put a dot at 0. I have a y-intercept also at 0. It's in the exact same place. I'm not going to mark it twice. Now I'm going to mark my asymptotes. Again, asymptotes are dashed lines because your graph doesn't live there. So I'm going to have a vertical line at -5. So when x is equal to -5, the graph doesn't live there. So I'm going to put a dashed line way over here. And then I have another another asymptote when x is equal to, or sorry, when y is 1, your graph doesn't live there either. So I'm going to put so those are my two asymptotes. I was looking for the words. And now I'm going to plot on my graph. So the graphs of these look a lot like the graphs from last time. And so this graph is positive because there's not a negative out here. And since it's positive, it has to live above the x-axis. After it leaves this intercept, it has to continue above the x-axis. but it has to conform to the asymptote. So it has to look like this as it leaves that root. But these graphs are going to look a lot like the graphs we created last class, where you've got the two branches that are opposite of each other. So this one is going to end like that, but continue down and kind of come down here and follow this asymptote. So that's one part of my branch. And then at this asymptote, nothing is together. So when we graph it, it has to be apart. So if this one is facing down, then up here, this side has to be facing up. And it has to follow the asymptote. So it has to be a shape like this. So they look a lot like the graphs from last time. And so again, the reason why I chose to put this one up here is because these have to be apart because there was no togetherness. So these have to be apart. And that's it. No, that's it for this one. Yes, we're going to do the other one. First, before we do anything, let's identify the solutions. The solutions are the same thing as the roots. So x is equal to what? 6. And I can identify that before I ever even graph. I'm going to mark up my graph with intercepts and asymptotes. So these are my intercepts and these are my asymptotes. I also need to mark my hole. So intercepts, I have an x-intercept at +6 and a y-intercept at 0 and then -3/2. -3/2 is like -1.5. I mean, you could find the decimal equivalent if you needed to. So at about -1.5, I'm going to put my y-intercept. Now I'm going to put on the hole. The hole is at -2, -4. So I'm going to go and mark it. And the way that I'm going to mark it, I'll show you. -2 and then -4. I'm going to mark my hole with a hole there. So I'm marking it as a hole. So I need to know that I go to that point, but I'm going to leave it as a hole so that it's marked as a hole. That's how you graph a hole. I'm going to put on my asymptotes. So the vertical asymptote is over at -4. So -4, I'm going to put in an asymptote. And then I have a horizontal asymptote at 1. So through 1, I'm going to have a horizontal asymptote. I can already tell by how I've marked my graph that the way that my graph, one of my branches is going to travel. Do you guys see how it makes sense that my graph is going to travel like this and have to hit all of the points that we just marked? Okay, so that's one branch. And there's no togetherness, so it has to be apart. So one branch is going to follow through those points, and then one is just going to be floating up here following the asymptotes. So I'm going to make my branch go through these points. And then down like this. And then my other branch is going to be up here, just following the asymptotes. And that is it. Our last day of notes. You made it. Please use your time wisely and let's get started on the homework.